Welcome. I'm super excited to welcome you to today's presentation on how to securely manage your industrial IoT digital transformation. I'm Ryan D'Souza with AWS, and thank you again for joining us today. Let's go ahead and take a look at the agenda. So these are the topics that I put together for today's presentation. We're going to start with the level setting on Industry 4.0 and the common challenges in industrial IoT security. We'll then jump into what we call best practices or golden rules for industrial IoT security. What we're then going to do is apply the golden rules to a customer case study. We'll then talk about the key elements and features of industrial IoT security on AWS. We'll then follow with security compliance and governance on AWS. And we'll finally do a wrap up. As you can see, we've got a full agenda for today. So I would say let's jump right in. So the first topic we're going to tackle today is level setting on Industry 4.0 and the common security challenges in industrial IoT. As you can see, digitization in industry is accelerating at a rapid pace. And the three biggest opportunities for digitization in industry is smart and connected products, smarter manufacturing operations, and smart supply chains. And these three big opportunities can lead to improving operational efficiencies, reducing unplanned downtime, reducing costs, improving productivity, and also creating new revenue opportunities for manufacturers. And this is what industry experts term as Industry 4.0 or the fourth industrial revolution. And while manufacturers are embracing digitization and embracing smart manufacturing, it is important to do it securely as well as safely. And there are some security challenges that need to be addressed. Let's go ahead and take a look at some of those security challenges. So these are the common security challenges that we have seen with industrial IoT. There is a general lack of risk mitigation when it comes to the factory and industry in general. You have the OT folks that may not understand IT security principles. You've got IT teams that may not understand operational technology. And this often results in a lack of a comprehensive strategy towards risk mitigation when it comes to the factory. The second is there exists multiple component vulnerabilities. So industrial IoT and industrial control systems, legacy industrial control systems have been insecure by design. And they were not designed to operate in an open network. They were in fact designed to operate in a closed environment or an air-gapped environment. And now with industrial IoT and the OT-IT convergence, these legacy industrial systems that were insecure by design are being exposed to many vulnerabilities. The third is lack of endpoint visibility. In order to secure operational technology and in order to secure the factory, you need to first have visibility into what you have on the factory floor, how these systems are interconnected, and this is often lacking. The fourth is security updates. Doing security updates and software updates in an OT environment is always a challenge because you got to ensure that when you do software updates, you don't cause unplanned downtime. And you also don't pose any safety risk because you're dealing with life safety critical systems. Also, the common over-the-air update technologies that we are all familiar with in IT is not always available in the operational technology environment. And last but not the least is that you're dealing with lots and lots of insecure industrial protocols that don't support the latest authentication, authorization, and encryption technologies. And keep in mind, all of these security challenges need to be addressed, and it needs to be addressed safely and keeping reliability in mind. So let's quickly take a look at architecting security for OT or operational technology. Many of you are familiar with the CIA triad, where confidentiality, integrity, and then availability of data is important in IT. So you can see that you're more concerned with confidentiality of your data when it comes to IT security. When it comes to OT security and IIoT security, the key consideration is availability because you're dealing with production systems and these production systems need to be up and running and you don't want to cause any unplanned downtime. So availability of production systems is the most important parameter to think about when designing for OT security. In addition to that, you've got safety concerns. You've got to basically ensure that you maintain safety for people as well as the environment. And then last but not the least is you're also dealing with regulatory compliance and regulatory compliance requirements for specific industries when it comes to architecting for operational technology security. Now let's jump into the top 10 security best practices when it comes to industrial IoT security. And this is also what we call golden rules for industrial IoT security. So golden rule number 1 is to conduct a cybersecurity risk assessment. We recommend that customers start with doing a risk assessment, and you can use a common framework like MITRE ATT&CK and create a threat model and use that to then inform your system design. What is also important is to do network segmentation, and this is OT network segmentation. So you got to basically segment your OT network using micro network segmentation, using firewalls and unidirectional gateways. If you have assets that are insecure and you're unable to isolate them and protect them, our recommendation is to disconnect those insecure assets from the network. Let's look at golden rule number 2. So golden rule number 2 is to maintain an asset inventory as well as an up-to-date network architecture. So it's super important to know what assets you have on the shop floor as well as at the edge and in the cloud. You need to understand how these assets are interconnected, which means you need to maintain a network architecture. You also need to categorize these assets as safety assets based on their criticality. Were they designed for air-gapped environments or were they designed for open networks? Are they patchable or not patchable? As well as understand how these assets are all connected, which is creating an asset hierarchy, but also how these OT assets are connected to IT systems and the internet. Let's look at golden rule number 3 or best practice number 3, which is identity and access management. When it comes to modern IIoT devices, these are new devices for industrial IoT that you're introducing into the shop floor environment. These could be edge gateways. These could be OT IT gateways. They could be camera systems. They could be modern sensors. It's important to have that these devices have unique identity. So this best practice is that every modern IIoT device that you introduce into the shop floor environment needs to have unique identity. And you need to apply authentication and access control mechanisms. Let's look at golden rule number 4. Golden rule number 4 is about doing a mechanism for software updates and patch management. And this includes both your OT devices as well as your IIoT and your edge devices. You need to have a mechanism to apply software patches. But you also need to make sure that you do that in a safe and secure manner, okay? Because you're dealing with life safety critical systems. So maintaining availability of the systems and keeping security in mind is super important when you do software updates in an OT environment. Let's look at golden rule number 5. So golden rule number 5 is about encrypting data at rest. So it's important to secure manufacturing data at rest, both at the edge as well as in the cloud. It is very common in industrial applications to bring industrial IoT data into a data lake and then have that data shared with different stakeholders in order to build industrial IoT applications as an example. So it is very important to have a mechanism for secure data sharing, governance, and sovereignty. Let's continue with the golden rules for industrial IoT security. So golden rule number 6 is to encrypt data in transit. We already talked about encrypting data at rest. We also got to encrypt data in transit. And for that, you've got to use cryptographic network protocols. These are secure protocols that support encryption. As you know, in the OT environment and in a factory setting, it's not always possible to use secure protocols. There are many legacy industrial control systems that support and use insecure protocols. Our recommendation is that when you use insecure protocols, it is important to convert the insecure protocol to a secure protocol as close to the source as possible. Golden rule number 7 is about hardening your devices. And these are OT devices and IIoT devices. It's important to harden all your devices, but super important to prioritize and secure and harden your internet-connected devices. So these could be edge gateways, for example. It's also important to establish a secure connection from on-prem systems to the cloud and also secure remote access to on-prem systems. Let's look at golden rule number 8. So golden rule number 8 and best practice number 8 is about audit and monitoring. So you've got to have continuous audit and monitoring mechanisms. And these audit and monitoring mechanisms is across the OT environment, across the edge and the cloud. And you've got to centrally manage security events and alerts. Let's look at golden rule number 9. Golden rule number 9 is about incident response. So it's very important to have an incident response playbook with very clearly defined roles and responsibilities. It's also important that you test your incident response playbook frequently. And last but not the least, golden rule number 10 is about business continuity and disaster recovery. So you need to have a plan for business continuity and disaster recovery, and also a plan to take OT backups. So your OT data needs to be backed up in the cloud, and don't forget about cyber security testing. So with that, those are the 10 security golden rules and best practices for industrial IoT security. Let's go ahead and take a look at the next second. What we're going to take a look at now is our industrial IoT security architecture. And when we look at this architecture, we're going to map this architecture to the golden rules that we just reviewed. And we're also going to look at the different AWS services that help support these golden rules. So as we look at this industrial IoT security architecture, you can see that it is based on the ANSI ISA 95 model. You can see the different layers at the bottom of this architecture. You've got layer 0, which is your industrial equipment and your machinery. You've got layer 1 and 2, which is your industrial control systems. So these are your industrial automation systems. It includes PLCs, DCS, HMIs, SCADA systems. At layer 3, you've got manufacturing execution systems. Layer 3 is also in the OT network, and we've introduced the industrial edge. So this is where you can see different AWS edge products and solutions at layer 3, which is in the OT network. Some examples include Snowball Edge. You can see AWS Outpost. You can see AWS IoT Greengrass. All of these software tools and services can be used in layer 3 in the OT network. Between layer 3 and layer 4 is the IT network, layer 3 is yet the OT network. So you need to secure the OT-IT network boundary. So that is between layer 3 and layer 4. And the way we secure the OT-IT network boundary is by introducing an IDMZ. An IDMZ is an industrial demilitarized zone. And in the IDMZ, you can see we have a TLS proxy and IDS IPS. So it's very important to secure the OT-IT network boundary. At layer 4 and layer 5 is your IT network and the AWS cloud. As you look at the different services in the AWS cloud, what we have tried to highlight here is the different AWS IoT services and also the different AWS security services that are used in industrial IoT projects and applications. So with that, what we're now going to do is we're going to map out the golden rules to the industrial IoT security architecture. What we're going to do now is take a look at the 10 golden rules and map it to the industrial IoT security architecture. The first golden rule is a cybersecurity risk assessment and conducting network segmentation. So it's important to conduct a risk assessment and use that to inform system design. In network segmentation, you got to segment your OT network by doing micro network segmentation and tighten the trust boundaries using firewalls and unidirectional gateways. Let's take a look at cell number 1, which is at the top of this slide. You can see here we've got insecure industrial control systems that use insecure protocols. And as part of our golden rule, we're going to convert the insecure protocol to a secure protocol using a protocol converter. So you can see in cell number 1, we're using protocol converter to convert an insecure protocol like Modbus or Ethernet IP into a secure protocol like MQTT. Let's look at cell number 2. In cell number 2, we have insecure or legacy industrial control systems but in this case, we are using a data diode or a unidirectional gateway. So this way, we can get data out of the cell, but we don't allow any commands to go back into the cell. If we look at cell number 3, we've got modern control systems, and these modern control systems can be configured to use secure protocols. And in cell number 4, we've got a smart connected device that can support the MQTT protocol. So this is applying golden rule number 1 to the industrial IoT security architecture, conduct a cybersecurity risk assessment, and do OT network segmentation. Now let's take a look at golden rule number 2. So golden rule number 2 is about managing an asset inventory and maintaining an up-to-date network architecture. As you can see, you've got a number of assets in your OT network as well as at the edge. You can use AWS IoT Device Management in order to manage the asset inventory for devices connected to AWS IoT. And you can use Systems Manager Inventory in order to manage the inventory of cloud compute as well as your on-prem compute resources, okay, like your edge gateways and edge computers. So that's golden rule number 2, mapped to the IIoT security architecture. Let's take a look at golden rule number 3, which is having unique identities and maintaining authentication and access control mechanisms. So you can use AWS IoT Core in order to ensure that every device has a unique identity. So every device is given a unique identity with an X.509 certificate or a custom authorizer when using AWS IoT. There's mutual authentication where the device needs to authenticate with the service and the service authenticates with the device. You can use AWS IoT policies to maintain fine-grained authorization. All data is encrypted using TLS 1.2. You're using MQTT on specific ports such as port 8883 and port 443. All connections to the cloud are device originated. So you have device originated connections as compared to no cloud originated connections. And finally, continuous logging, auditing, and monitoring. You can use IAM in order to manage the identity for AWS services and resources and to secure those resources, and Cognito for identity in web and mobile applications. Let's take a look at golden rule number 4 or best practice number 4, which is you need to have a mechanism for software updates for your OT devices as well as your IIoT devices. So you can use AWS IoT device management jobs in order to do software updates on devices connected to AWS IoT. And you can use Systems Manager, Patch Manager in order to patch on-prem computers and resources. As we look at golden rule number 5, it is protect and secure manufacturing data at rest. And this includes securing data at rest at the edge as well as in the cloud. So you can use KMS or the key management service in order to manage the encryption keys that are used to encrypt the data. For FIPS 140-2 industrial IoT applications, you can use Cloud HSM. You can use Secrets Manager to secure secrets at the edge as well as in the cloud. And you can use Macie in order to discover and protect sensitive industrial IoT data at scale. Golden rule number 6 is to encrypt data in transit. So we use cryptographic network protocols whenever possible. In many cases in the OT environment, as we discussed, you have legacy industrial control systems that use insecure protocols. In such cases, you can use a protocol converter to convert an insecure protocol to a secure protocol, and our recommendation would be to do that as close to the source as possible. You can use protocol converter products from Kepware, Matricon, Ignition, Softing, and others in order to do this industrial protocol conversion from an insecure protocol to secure protocol like MQTT. You can use AWS IoT device SDKs as well as free RTOS libraries in order to securely connect devices to AWS IoT services. Let's look at golden rule number 7, which is harden all your devices and especially internet connected devices. So you can use the security features available in AWS IoT Greengrass, such as TPM and secure elements in order to secure the credentials on the edge gateway. You can use AWS IoT Device Management tunneling feature to securely connect to on-prem resources and IoT devices that may be behind firewalls. You can use Systems Manager, Session Manager in order to securely connect to computers and on-prem resources without opening inbound ports. You can use Direct Connect and site-to-site VPN to securely connect to AWS, and AWS IoT now supports VPC endpoints, so you can use VPC endpoints with AWS IoT Core, AWS IoT Greengrass, and AWS IoT Sitewise. Golden rule number 8 is about security, auditing, and monitoring. And you got to audit and monitoring across OT, edge, as well as the cloud environment. You can use AWS IoT Device Defender to audit and monitor your IoT devices at scale. You can use GuardDuty as a threat detection service in order to protect your IIoT applications in the AWS cloud. You can use Security Hub in order to, as a single pane of glass, to consolidate all your security events in one place in the AWS cloud. You can use Amazon Detective for security investigations, CloudWatch in order to monitor your AWS services and resources, and CloudTrail for your API activities. So let's map out golden rule number 9, which is having an incident response plan. So you need to have an incident response playbook that you test frequently with clearly defined roles and responsibilities. You also got to be ready to take mitigation actions. So you can use AWS IoT Device Defender to take mitigation actions. And those mitigation actions could be revoking permissions, revoking certificates, pushing a software update, quarantining a device, and many others. You can use AWS IoT Device Management jobs in order to push software updates to IoT devices. Security Hub and Detective we already spoke about, and Systems Manager in order to basically respond and do common tasks on your AWS resources. So finally, golden rule number 10, which is business continuity and recovery plan. You can take backups using S3 as well as AWS Backup and Storage Gateway. You can use AWS IoT Greengrass features in order to manage the intermittent connectivity to the cloud. It's important to back up your OT data, and it's also important to do ongoing and continuous cybersecurity testing. So what we have looked at so far is the 10 security golden rules as well as the Industrial IoT reference architecture. We are now going to apply the golden rules to a customer case study. So this customer is a global product distribution company. This company manages lots of warehouses all across the world. And in these warehouses, they have a lot of industrial machines. So in this case study, we're going to take a look at one of their industrial machines, which is used for identifying a package, printing a label, and then applying the label to the package. So let's jump in and take a look at this customer case study. So the first thing we're going to take a look at is their legacy architecture or their previous controls architecture. As you can see, as the package moves along the conveyor belt, you've got this machine that is going to identify the package. It's going to print a label, and then it's going to apply the label to the package. So this machine has got a controller, and that's a programmable logic controller. With the PLC, you can see there's a printer that prints the label. There's a camera that basically makes sure that you're applying the right label to the right package. And this is on a local control network. So you can see it is on-prem, it's in the warehouse, and there's a local network. This PLC then connects to a warehouse management solution, and it goes through a firewall and a VPN connection. Let's take a look at some of the limitations with this architecture. The first is limited compute and memory on the controller, and the controller in this case is the PLC. So this is a traditional PLC which has got limited compute and limited memory capability. In addition, this PLC does not support modern programming languages. Also, the data that is being sent to the warehouse management solution is not being encrypted in transit. So there is no TLS 1.2 support for transmitting the data from the controller to the warehouse management solution. In addition, doing code deployments and making code changes to the PLC is a manual process and can take a lot of time and effort. So if you look at the limitations with this architecture uses a traditional PLC that has got limited compute and limited memory capability. It does not support secure protocols. So in this architecture, you're using an insecure protocol, which in this case is Ethernet IP. Making code changes and updating software on the PLC is a manual process. And there is no support for edge computing and edge analytics in this architecture. What we're now going to look at is the modern architecture. So this machine has been modernized, and we now have a retrofit architecture as well as a greenfield architecture, which I'm going to get to. So as you can see in this architecture, we've introduced an IPC or an industrial PC as an edge computer or edge gateway. And this IPC runs AWS IoT Greengrass, which is an edge runtime that is used to build and deploy edge applications. In this IPC, we've got two containers. We've got a soft PLC and we've got the work cell software. This IPC runs the Ubuntu operating system. We have not made any changes to the local network and the local devices. So you can see we yet have the PLC, we yet have the printer and camera connected to a local network. So what we've done is that we've introduced an IPC, we've connected it to existing equipment. The IPC now establishes a secure connection to AWS IoT. So in this case, what we have is mutual authentication between the gateway and AWS IoT core. All data is encrypted using TLS 1.2. We've got a fine-grained authorization using IoT policies, and we've got a much better and more secure solution in this architecture. So if I tie back to the golden rules, with the printers and cameras, we maintain this in an asset inventory, so we know what OT assets we have. Golden rule number 6, which is to encrypt data in transit using TLS 1.2. And golden rule number 1, which is a network segmentation. So you can see we've used network segmentation in this architecture. This is the greenfield architecture. It's very similar to the retrofit architecture. In the greenfield architecture, because we don't have any existing machines, and this is a new machine, we can get rid of the PLC completely. So you can see that we don't have any PLC in this architecture. We directly connect to remote I/O. The PLC that we have is running on the IPC, which is a soft PLC using the Codesys software. So what are some of the new network architecture benefits? The first is we have a fully managed edge compute device with an edge gateway running AWS IoT Greengrass, which is an edge runtime to manage, deploy, and build edge applications. What we have is two containers. So we have separated out the PLC or control logic with the warehouse software logic running at the edge. We've got support for secure protocols. So we're using HTTPS and MQTT. All data is encrypted at rest as well as in transit. We now have support for pipelines. In the earlier architecture, it was a manual deployment. It used to take a lot of time and effort. Now we've got CI/CD and pipelines in order to deploy changes to the edge. You've got telemetry data as well as bulk sensor data. This bulk sensor data is images. And these images, as well as the telemetry data, is now sent to AWS. What this means is that we can now use this data to build machine learning models, and we can deploy those machine learning models to run at the edge for edge analytics. What we'll now take a look at is go through the security of this architecture step by step. So first, we'll take a look at user authentication. How are we authenticating users for this industrial IoT application? After we've authenticated the user, we're going to look at device identification and device authentication. We're then going to look at how we register the device with the platform. After we've registered the device with the platform, you've got to deploy software or install software such as Greengrass and the Codesys soft PLC on the IPC or edge device. After that, you've got to deploy your application. So that would be the work cell application, as well as your soft PLC or your control application. It's important to look at securing data at rest and in transit, and I'm going to show you how we do it in this architecture. And in addition to connecting to AWS IoT, the edge device also makes calls to other AWS services. So we'll take a look at how do we do that in a secure manner. So with that, let's jump right in. So the step number one is to authenticate the user. So the user that is going to deploy this application and is going to provision this edge gateway needs to be authenticated. And we're using the OAuth 2.0 standard. So the edge device makes a request to the federated identity broker, which is a custom application. What gets returned is an access token when you follow these steps. And finally, the user is able to use that token in order to authenticate with EDM or Edge Device Manager. Edge Device Manager is the application that is used for provisioning and onboarding edge gateways and edge devices. So that's how we follow step number one, which is to authenticate the user, get the user authenticated, to use the Edge Device Manager to now onboard edge gateways. And this ties back to golden rule number 3, which is every user needs to be authenticated and you've got to use access control mechanisms. So now that we've authenticated the user, let's go into step number 2, which is device identification as well as device authentication. And you can see over here, we're using a TPM 2.0, which is a trusted platform module. So this is a TPM that is being provided by the vendor of the edge gateway. And with this, we have a secure boot. We've got hardware root of trust, which is more secure. And we have the ability to secure credentials and store credentials in the TPM module. So using this flow, you can see that we are able to ensure that the edge gateway has come from a trusted source, and we're able to authenticate the edge gateway with the EDM application or the Edge Device Manager provisioning application. And this ties back to golden rule number 7, which is you got to harden your devices, all your devices, but especially internet connected devices. So using the trusted platform module, we're able to harden the edge gateway. So now that we have authenticated the device, we now need to register the device. And what we follow is the AWS Systems Manager hybrid activation model. So the Edge Device Manager makes a request to Systems Manager to get the activation key and ID. Once the Edge Device Manager gets the activation key and ID, it installs the SSM agent on the edge gateway on the edge device. And that way, the device is able to register and connect to Systems Manager and get registered in Fleet Manager. Essentially, what we're doing in this step is making the edge gateway a managed instance or a managed device for AWS Systems Manager. So now that the device is registered with AWS Systems Manager, the next step is to start the software installation process. And in this case, we're using Systems Manager command documents in order to execute these steps. So we secure the device and store the credentials in the TPM. We do OS patching on the edge gateway. We install CloudWatch agents, so we're able to get logs and do monitoring of the edge device. We installed other applications such as AWS IoT Greengrass and Codesys, which is a soft TLC runtime. We apply network configuration and finally configure the device with firewall rules. So let's look at how this ties back to the golden rules. So golden rule number 7, which is to harden your edge devices. And we're using TPM 2.0 or the trusted platform module. Golden rule number 8, which is CloudWatch, using CloudWatch for monitoring and logging. Golden rule number 4, which is software deployment. So you need a secure mechanism to deploy software on your edge devices and edge gateways. And golden rule number 3, which is every device should be given a unique identity. And in this case, the edge gateway is given a unique identity with an X.509 certificate, which comes from AWS IoT Greengrass and AWS IoT Core. So now that we've installed the edge gateway and it is ready, we now need to start thinking about and deploying workcell application software. So we're now going to deploy applications onto the edge gateway. And the first application that we're going to deploy is the workcell application. So in this case, we're using AWS IoT Device Management jobs in order to manage the software installation and software deployment of the work cell application onto the edge gateway. So we use pipelines. Once the pipeline is triggered, you've got AWS IoT jobs that is going to look at, do you want to install the software on a single edge gateway or on a number of edge gateways, which is a group. So once it identifies that, it sends the job to AWS IoT Greengrass Lambda function. The Lambda function is able to pull the image, which is an Amazon ECR because it's a Docker image. The software gets deployed, the work cell application software gets deployed on the edge device. And finally, a status update and notification is sent back to AWS IoT jobs. So this ties back to golden rule number 4, which is you need a mechanism to do software updates, secure software updates on your edge devices. And by using AWS IoT device management jobs, we're able to accomplish that. The next software that we need to deploy is the PLC code. So we're using a soft PLC, which is Codesys. This architecture is very similar to the earlier architecture. What changes over here is that the PLC code the final PLC code that comes from the pipeline is loaded into an S3 bucket. And the other difference in this step is that a notification is sent to the local operator through an HMI. Because this is PLC code, it is important that the operator acknowledge that new software is available to shut down the machine, make sure it is safe, and then do the update on the soft PLC. So that's how we do deployment of machine control software using, again, AWS IoT device management jobs. So this ties back again to golden rule number 4, which is secure software deployments onto your edge devices. We mentioned earlier that it's important to secure data at rest and in transit, which is golden rule number 5 and golden rule number 6. So over here, you can see that we're using a secure VPN, which ties back to golden rule number 7, which is to securely manage on-prem resources. So using secure VPN, we can SSH into the edge device. Golden rule number 6, which is to secure data in transit, and we're using TLS 1.2. Golden rule number 1, which is network segmentation. So you can see we've applied network segmentation. We have isolated the insecure assets in a local network. We're using very specific ports for communication, such as port 8883 and port 443. And we've also secured data at rest on the edge gateway by doing full disk encryption. The next, we're going to look at authoring direct calls to AWS services. So we mentioned that every device is given a unique identity. That identity is an X.509 certificate or could be a custom authorizer. With that, the device is able to securely connect to AWS IoT services. But what happens when the device wants to connect to other AWS services, such as S3 or DynamoDB or some other AWS service? Those services don't use certificate-based authentication. The other AWS services use AWS SigV4 and needs an access key and a secret access key. It's not recommended to store access keys and secret access keys on the edge device. So in this case, we're using AWS IoT as the credentials provider. So this is how it works. The device connects to a credentials endpoint, an AWS IoT credentials endpoint. After it is authenticated, you get temporary credentials, and those temporary credentials are STS credentials. So you get a secret access key, and a token. That is then given back to the device, and the device is able to use the temporary credentials from STS, the token, in order to securely connect to other AWS services. So as you can see over here, by using AWS IoT as a credentials provider, an access is made to AWS IoT Core to get temporary credentials. Those temporary credentials, as you can see in number 2, is provided to the device. The device uses those temporary credentials to then access Amazon CloudWatch as well as Amazon API Gateway. And this ties back to golden rule number 3, which is ensure you have authentication and access control and fine-grained authorization. So now that we have taken a look at that case study and how we applied the golden rules to that case study, we're now going to look at the key elements and the key aspects of industrial IoT security on AWS. So AWS recommends using a multi-layered security approach with different and multiple AWS security services. So AWS offers a lot of different security services to identify threats, to protect your infrastructure, to detect anomalies, to respond and mitigate, and finally recover. And recovery is not just about data, it's about applications, it's about infrastructure, and about devices. So you can see here, AWS offers lots of different security services that customers can use to secure their industrial IoT applications. Customers don't need to implement all these services. They may already have some security services, in which case they can pick and choose what they need and integrate with what they have. We believe that this approach gives customers lots of choices and flexibility when it comes to securing their industrial IoT applications. So let's go ahead and take a look at some of these security services. The first one being AWS IoT Device Defender. So AWS IoT Device Defender is a security service that can audit and monitor your IoT devices at scale. With the audit feature, you can audit the security policies associated with your devices to ensure that they aren't deviating from security best practices. And audit provides 14 security best practices. With Detect, you can detect anomalies in your device behavior using analytics. You get alerts when there are anomalies, and finally, you can take mitigation actions. And the mitigation action could be to quarantine a device, to change its permission, to reduce its permissions, to disconnect the device from the platform. So lots of mitigation actions that can be taken directly from AWS IoT Device Defender. Another service we're going to take a look at today is called GuardDuty. And GuardDuty is a threat detection service. It's meant to secure and protect your IIoT applications in the AWS cloud. It uses network flow logs and DNS logs and CloudTrail events. So it analyzes this information and it uses threat intelligence as well as machine learning in order to identify threats more accurately. So you can use GuardDuty as an intelligent threat detection service to secure your industrial IoT applications in the AWS cloud. The next service we're going to take a look at is Systems Manager. So when you build industrial IoT applications on AWS, you use a number of different AWS services. So it's important to gain operational insights, but also be able to carry out routine maintenance tasks. So what are some of these routine maintenance tasks? You may need to patch your instances. You may need to patch your edge gateways. You may need to do the patching during a certain maintenance window. You may want to connect your edge devices and edge gateways using Session Manager in order to securely connect to those edge gateways. You may want to store your secrets and passwords in parameter store. You may want to also plan and prepare for incidents and respond to incidents. So you can use Systems Manager in order to gain operational insights in your AWS environment and take actions to recover using this service. The next service that we're going to take a look at is called Security Hub. So you're using all these different security services in the AWS cloud. It is important to bring all these security events to a single location so that you can aggregate them and prioritize security alerts. Security Hub provides you a single pane of glass for all your security events in the AWS cloud. That way, you can conduct security investigations. You can conduct those investigations as well as take mitigation actions. So now let's summarize the key elements of AWS Industrial IoT Security. As you can see, for connected asset inventory, you can use device management as well as Systems Manager, and that ties to golden rule number 2. For identity and access management, you've got AWS IoT, AWS IAM, and Cognito for your web and mobile applications, which ties to golden rule number 3. You need a mechanism to do secure software updates and patching, which ties to golden rule number 4, and you can use AWS IoT Jobs as well as Systems Manager. Golden rule number 7 is to harden your devices and especially your edge devices that are connected to the internet, and you can use AWS IoT Greengrass. You can use secure elements available with your edge gateway, as well as Secrets Manager to secure secrets at the edge. We have multiple services in order to establish a secure connection to the AWS cloud. You got to encrypt your data at rest as well as in transit, and that ties back to golden rule number 5 and 6. Golden rule number 8 for continuous audit and monitoring. We've got a number of services to help there. For alerting and mitigation and incident response, we've got a number of services like AWS IoT Device Management, Device Defender, SNS for notifications, and Systems Manager. And last but not the least, for backup and recovery, you can use AWS Backup, AWS IoT Greengrass, as well as Storage Gateway in order to take OT backups at the edge as well as in the cloud. We'll now transition to security, compliance, and governance on AWS. When industrial customers build industrial IoT applications on AWS, it is important for them to understand the AWS shared responsibility model, where security and compliance is a shared responsibility between AWS and the customer. And this differentiation of responsibility is commonly referred to as security off the cloud versus security in the cloud. So AWS is responsible for the AWS global infrastructure, and customers are responsible for their applications and data that they put in the AWS cloud. And AWS offers lots of prescriptive guidance to help customers with this aspect. When it comes to edge and edge computing, industrial customers need and want to process data at the edge close to where the data is generated. So for them, we have the shared responsibility model for the edge, where AWS takes on additional responsibility in order to protect the AWS managed hardware and software that the customer basically uses on the customer premise. So this is the shared responsibility model for the edge, where AWS takes on additional responsibility. In order to aid compliance efforts, AWS monitors and maintains third-party validation for thousands of different compliance requirements from around the world. And customers can inherit these security controls. And information about these compliance controls can be found in AWS Artifact. So finally, let's do a quick wrap-up on the session today. So we talked a lot about security and the different security services that AWS offers. In addition to that, AWS has the largest security partner and solution ecosystem. So in addition to AWS services, we've got partner solutions and services that can help you secure your OT environment, the edge, as well as the cloud. And AWS has been serving industrial customers for many years. And this is a sample of some of the industrial customers that are on AWS. So finally, as a summary, AWS recommends a multi-layered security approach and services. AWS offers lots of different security services that customers can pick and choose in order to secure their industrial IoT applications. There are many industrial companies, some of them being Amazon, the Volkswagen Group, Enel, VPX Energy, Lockheed Martin, and many others that are running their core production operations, core production applications on AWS. And they're able to do that safely and securely. AWS Security, Industrial IoT Security is built on well-recognized industry standards such as NIST, NERC-CIP, IEC 62443, and many others. AWS provides lots of prescriptive guidance to help customers. We've got the OT security white paper. We've got well-architected reviews. We've got the 10 security golden rules for industrial IoT security blog posts. So we've got lots of prescriptive guidance that can help customers secure their industrial IoT applications on AWS. And finally, AWS provides an easier, quicker, and more cost-effective path to achieve security and compliance when it comes to industrial IoT applications on AWS. So one more slide, and that is security skills. It's super important to have the right cybersecurity skills in your organization. AWS offers a number of free digital courses. In addition to that, there's classroom training available, and there's a security specialty certification exam. So lots of resources available in order to get skilled with cybersecurity on AWS. And with that, I want to thank you for joining us today. I'm Ryan D'Souza, and thank you for your time.